solving log and exponential equations. This one's probably going to be kind of long. Of course, as soon as you opened up this video, you probably went ahead and looked to see how long it was. But since I just started recording, I don't know, so it's going to be a surprise for me. Whoops. So you may need to take a break somewhere in the middle. I'm not sure. So solving these equations, we've actually done some of this. Let's start with exponential equations, which means you have a number to a variable power. The first thing we're going to try to do, and this is stuff that we've been doing already, is to write both sides with the same base. So if we look at this example, I have 4 and 32 as my bases. I know that I can write 4 as 2 squared to the x, and 32 I know is 2 to the 5th. We'll see, 2 to the 2x. You multiply those exponents, equals 2 to the 5th. And if you write them with the same base, as soon as you get 2 to some power equals 2 to some power, then you can set the exponents equal to each other. And I now solve the equation 2x equals 5. 2x equals 5, we'll divide by 2, and you get x equals 5 halves. So that's going to be strategy number 1. To try to write both sides with the same base. Sometimes that's not going to be possible though, and that's what I have right here for number 2. If number 1 isn't possible, then we will use natural logs to bring the exponents down. And what we're going to do is we're going to take advantage of that property that says ln of x to any power is the same thing as n times the ln of x. We're going to use that property. I think our textbook actually uses log, not ln. They use log base 10, but they both work. Since I cannot write 4 and 10 with the same base, 4 is 2 squared, but 10 is not 2 to some power, so I don't have the option that I had with number 1. So I will take the natural log of both sides of the equation, and when I do that, I get to write this as 4 times the natural log of, whoops, not 4, x times the natural log of 4. So I just take this x, and I bring it down front, and then that's going to equal the natural log of 10. And then to finish solving for x, we are simply going to divide by the natural log of 4. So we'll divide by natural log of 4, divide by natural log of 4, and that gives me an answer of x equals, those cancel, the natural log of 10 divided by the natural log of 4, and there's your answer. It's kind of ugly, you can't really wrap your brain around that, but you know, there it is. So let's do a few examples of solving exponential equations. And remember, the first strategy is going to be to try to write both sides with the same base. And this one I can do that because I have 6 to some power. This is 36, and I'm crazy smart. I know that 36 is 6 squared, and that would be 2 to the x plus 1. The right side I don't have to change because it's already with the base of 6. Well, now I've got to clean up the left side a little bit. If you have a power to a power, you multiply. So I'm actually going to distribute the 2. That's going to be 6 to the 2x plus 2 is equal to 6 to the x plus 6. And once you get both sides to have the same base, it's 6 to a power equals 6 to a power. You set those exponents equal to each other. 2x plus 2 equals x plus 6. And I'm going to assume you know how to solve that. Subtract the x, subtract the 2. You get x is equal to 4. And there's your answer for this one. So write both sides with the same base, if possible. If possible. Let's try this one. I have 1/2 and 64. Now this one's a little bit tricky because first you don't like fractions, and I put 2 fractions in this one, so you're already getting angry, and you're probably throwing your iPad against the wall or something like that. But let's pick it up and polish it off. I see a 2 here. I see 1 over 2. 64. I don't know if you know this, but 64 is 2 to the 6th power. So I'm kind of holding that in the back of my mind. So I know that I could change 64 to 2 to the 6th, and that would be raised to the 1/2 power. Now 1/2, if you remember, if you have a 1/2, that's the same thing as 2 to the negative 1 power. So there's something else we're going to take advantage of. 2 to the negative first is 1/2. So I'm going to take this side, instead of saying 1/2 to the x, I'm going to change it to 2 to the negative 1. To the x. And so I've changed 64 and I've changed 1/2 into bases of 2, and now I just need to clean up both sides. A power to a power we multiply, so that's going to be 2 to the negative x is equal to 2. 6 times 1/2 is 3. And then once you get both sides to have the same base, 2 to a power equals 2 to a power, I can solve the equation negative x equals 3 x equals -3. So there we go. Kind of a nice answer. Kind of a nice answer. You may disagree, but I say it is. Let's see, moving on. Getting a little bit uglier. I have 3 and 2. 9/4. If you know, 9 is 3 squared, and 4 is 2 squared, right? Well, this is suddenly starting to look a lot like that left side. So that's 3x over 4. The right side I'm actually just going to keep as it is. 3/2 to the x minus 5. Well, if 3 squared over 2 squared, that is actually the exact same thing as 3 over 2 all squared. So what I've done is I've changed 3 squared over 2 squared into 3/2 squared, and then that's all still being raised to the 3x over 4. Left side is still 3/2. And then lastly, I'm going to multiply. 2 times 3x over 4, that's 6x over 4. 2 times 3 is 6. 6 over 4 reduces to 3/2, so that's 3 to the 3x over 2 is equal to 3/2 to the x minus 4. And then I'll set both sides, my exponents equal. Now I have 3/2 to a power equals 3/2 to a power. So I can set the exponents equal. This was a brutal problem. This was a pretty brutal problem. So here we go. I will solve this. I don't like fractions, so I'm actually going to start by multiplying by the denominator, and that's going to get rid of my fraction. The 2 cancels. That'll be 2x minus 8 on the left side. Over here they cancel, and you just get 3x. And then we'll subtract the 2x, and you get -8 is equal to x. So there's how to do stuff if you have a fraction. That was kind of a brutal problem, though. Let's do a different kind. What about 4 to the x equals 13? We'll see. 4 is 2 squared, but 13, can't do anything with 13. 13 is not 2 to some power. So that, since I cannot write both sides with the same base, this is the kind where you'll take the natural log of both sides. That allows me to take this x and bring it down. So I have x times the natural log of 4 is equal to the natural log of 13. And then finish solving that, we'll simply divide by ln 4. Cancel, cancel. X is equal to natural log 13 over natural log 4. There's your answer. How does that make you feel? Good, good? Good, good. How are we doing on time? 7 minutes? Yeah, this one, I'm trying to go fast, but I don't want to go so fast that it's just a blur. I may be doing that. I'm not sure. Let's see. What about this one? We have a base of e. Now that's scary, isn't it? Nobody likes e. I'm not sure. E is nice. You know, 2.7, 1828, 1828, 4590, 4523. Let's see. So I have e and 6. There's no way I'm going to get the same base for that. So I will do the natural log of both sides. ln. And for the sake of being consistent, there is a little trick we could do with this one, but I'll be consistent. I'll do the same thing I've been doing. Anytime you take the natural log, we do that because it allows you to bring that exponent down. Now here's where you have to be careful. That exponent needs to be trapped in parentheses. It's 4 minus 3x all times the natural log of e is equal to the natural log of 6. And then here's a little trick. Not really a trick, but one of the properties of logs, ln of e is equal to 1. If you don't believe me, you can work that out and see for yourself. But since ln of e is equal to 1, this is saying 4 minus 3x times 1. And if you multiply by 1, it doesn't really change the equation. So this 1 is not needed. That ln of e just kind of goes away. And so now I've got 4 minus 3x equals the ln of 6. And I'm going to solve for x. And just remember, the natural log of 6, you treat that like a number. I'm going to start by subtracting 4. Negative 3x equals the ln of 6 minus 4. And then I will divide both sides by 3, negative 3. And this is kind of an ugly answer, but x equals the ln of 6 all minus 4 divided by negative 3. There's your answer. Ugly, ugly, but that's what you get. Remember that if you have a big exponent, you have to trap it in parentheses. You're good, you're good, you're good. I think there's one more of these. Yeah. So we have 4 to a power equals 5 to a power. Again, you're not going to get the same base, so I will do the natural log of both sides. And that's going to allow me to bring both of these exponents down. I can bring both of these exponents down, so that's going to give me, in parentheses, 3x minus 1 times the natural log of 4 is equal to x times the natural log of 5. And here's where you're going to, people see natural log and they quit thinking, but you need to remember natural log of 4, ln of 5, those are just numbers. They're ugly numbers, but they're just numbers. So we're going to solve this equation the exact same way you would solve it as if it were just 3x minus 1 times some other, we'll just say times 7, is equal to x times some number 6. If I had 3x minus 1 times a number equals x times 6, you would start by distributing that 7. So in this case, it'd be 21x minus 7 equals 6x, and you could finish solving that. If they were just nice, sexy numbers like 7 and 6, ln 4 we're going to treat the same way. We're going to distribute the ln 4 on the left side, and it's not going to be pretty, but 3x times ln 4 is simply 3 times ln 4 times x. You can't really do much with it. Minus 1 times ln 4 is equal to x times ln 5. And then anytime you're solving an equation, anytime you're going to solve an equation, you want to get the variable that you are solving for on the same side. So I'm trying to solve for x, and right now they are separated by the equal, so I need to get those together. So I'm going to move this whole thing, minus 3 ln 4 x, I'm going to move that to the other side of the equation. If I subtract it, 3 ln 4x minus 3 ln 4x cancels. On the left side, I'm left with negative ln 4 is equal to, on this side, nothing combines. It's x ln 5 minus 3 ln 4 times x. And then on the right side, what we'll do is we'll factor the x out. So we'll pull the x out. That leaves me ln 5 minus 3 ln 4. Left side I didn't change. And then finally, we get to divide by all of this stuff. ln 5 minus 3 ln 4. It's x times some garbly poo, so we'll just divide by the garbly poo, and this is going to be our answer. It's really ugly. You don't like the way this looks, and you're probably mad at me right now, because this is probably going to end up being upwards of about a 25-minute video, if not longer. But this is our answer for x. That's what x equals. Over here, all of those cancel, and you get x equals that ugly stuff. So there we go. If you want to take a break, this is probably a good time for a break, because we're about to get into solving log equations. Not as bad. I think the exponential ones are a little bit tougher, so the log ones aren't going to be as bad. But if you want to pause it and come back and take and go grab something to eat or something, I don't know, come back and finish the video in a minute. But there's solving exponential equations. And we finished with some brutal ones, but you have to be really careful with your work. All right, so solving log equations. Log and exponential functions are very closely related. We have two strategies. The first one, if there's only one log, or if you have like just a number floating by itself, like I have a 1 and a 5, what you want to do is isolate the log. So I'm going to isolate the log base 3 of x plus 1 equals 4. I'll move that 1 over. And then what we'll do is we'll take it out of log form. Log base 3 equals 4. We can change that to 3 to the 4th power is equal to x plus 1. We're just going to take it out of log form. And then we solve that equation. 3 to the 4th is 81 equals x plus 1. We'll subtract 1, and you get 80 is equal to x. So that's one strategy. If you can get it where you just have log equals a number, which is what I'm trying to say right here, log equals a number, then you take it out of log form. The other option, if you cannot just get it equal to a nice number like I did up here, right here I just had it equal to 5, which eventually became a 4, then what you'll do is you'll want to write it as log of something equals log of something, and then you can drop the logs. Now this one is almost in that form, but I have this 3 in front, so I need to take care of that 3. I'm going to bring it up as an exponent inside here, so that's going to be log base 2 of 4 cubed. On the left side, I don't have to change. Log base 2 of 3x plus 1. Then if you have log equals log and the bases are the same, the bases must match to use this property, then you can just ignore the logs and we'll set the inside equal. So 3x plus 1 is equal to 4 cubed, and 4 cubed is 64. Then we'll solve that equation and you'll get x equals 21. So those are our two strategies. take it out of log form by using that exponential property, or you'll just drop the logs on both sides. So let's try a couple of those. Number one here, ln x equals 6. Well, remember, ln is the same thing as log base e of x equals 6. If you have log equals a number, then you'll just take it out of log form. So I'll say e to the 6th power is equal to x. And then you're done. You've got x by itself equals e to the 6. I know that's ugly and you don't like that, but that's your answer. You can't really do much else with it. Let's see. What about number 2 here? It's a little bit hairy on the left side, but remember I told you to isolate the log if you can. So I'm going to start by subtracting the 4. You get negative 3 log 5x. If I subtract 4 from both sides, you get 12. So that's log of 5x. I will now divide by 3. And 12 divided by 3 is negative 4. And then this one, let's see, there's no base written. This just hit me. There's no base. If there's no base written, it is an understood base 10. If it's log without a base written, it's base 10. Now, ln is base e. So here, I'm going to take this out of log form. That's 5x is equal to 10 to the negative 4 power. And 10 to the negative 4, that's 1 over 10 to the 4th. And 1 over 10 to the 4th is going to be 10,000. 1 over 10,000. And then we will divide both sides by 5 to finish solving for x. That's the same as multiplying by 1/5. So we get x is equal to 1 over 50,000. Yeah. So if you can, write it as log equals a number, and then you'll take it out of log form. Sometimes, what happened here? Why do I have 2 minus 2's? That was 2 problems. All right, let's look at this one. Notice I don't have just any floating numbers like I had on the last problem. This problem I just had a floating 16 and a 6 and a 4. All of these problems for number 3 have logs attached to them, which means we're going to use strategy number 2 right here, where you write it as log equals log, and we drop the logs. So first thing I need to do is condense and write this as 1 log. And that's going to be pretty easy. Is what we did in class the other day. If you're adding 2 logs with the same base, you write it with multiplication. So that's going to be log base 3 of 3, or log base 4 of 3 times x minus 2. Left side is already just 1 log, so we'll just write that as log base 4 of x. And then if I have log equals log and the bases are the same, you can drop the logs, and you get x is equal to 3 times x minus 2, which is 3x minus 6. And solve that equation, you'll get x is equal to 3. I'm going to assume you know how to solve the equation from that point. So if you can, write it with the same log on both sides and then drop the logs. Let's see, looking at this one. Okay, this problem, I've got a floating 2. I've got a floating 2 sitting there, which means we're going to have to try to take this out of log form. I'm going to move this log. Hey, I'm writing in dots. How exciting. Move this log over. Combine it with the other one. And that would give me log of x minus 12 minus the log of x minus 2 is equal to 2. And then I need to combine my logs on the left side. If your logs are subtracted, log of something minus log of something, I can write that as a single log with division. So x minus 12 divided by x minus 2 is equal to 2. Now I can take it out of log form. Remember, if there's no base written, it's an understood 10. So 10 squared, which is 100, maybe I'll just write it as 10 squared. 10 squared equals x minus 12 over x minus 2. And then we solve that equation. We're going to multiply by x minus 2. Get rid of that denominator. Multiply this side by x minus 2. Those cancel. We get x minus 12 is equal to, and remember, 10 squared is 100. So that's 100 x minus 200. And then we'll solve for x. That's going to be 188 is equal to 99 x. And you get 188 divided by 99 And I'm not 100% sure if that's going to clean up. For the sake of time, I'm not going to simplify that, but you do need to reduce fractions. I don't think that one's going to reduce any. So that's an ugly answer, but there we are. Yeah. How are we? 20 minutes. That's about what I was expecting. One last thing. If you want to take one more break before we do this last thing, there's two more problems I want to look at. And these are exponential equations in quadratic form. If you remember what a quadratic is, that a quadratic is ax squared plus bx plus c, where problems like that you try to solve by factoring, or if I feel like being really evil, quadratic formula. So this is actually a quadratic form in disguise, and the way I'm going to force this to look like a quadratic is I'm going to treat e to the x like it's just one simple thing. But here I have e to the 2x. Well, I can rewrite e to the 2x. That can be rewritten as e to the x squared. It's the same thing. You multiply the exponents. So I have e to the x squared plus 6 times e to the x minus 16 equals 0. And if you look really closely at this, it looks an awful lot like the equation something squared plus 6 times that same thing minus 16. It looks an awful lot like that. It's something squared plus 6 something minus 16. And you could solve this by factoring. So I'd like to do substitution, and I'm going to make a substitution. I'm just going to let a equal e to the x. And if I let a equal 6 to the x, this equation becomes a squared plus 6a minus 16. And now it's not quite as intimidating. I'm going to solve that by factoring. Factors of negative 16 that add up to 6, that's going to be a plus 8. And a minus 2 is equal to 0. You get a equals negative 8. And you get a equals positive 2. So I solve for a, but remember the problem wasn't in terms of a. A is just kind of a stand-in to make the problem more manageable. So now that I've got it to this point, I put my e to the x back in, and I solve the equations. E to the x equals negative 8, and e to the x equals 2. Well, the way we solve those is, let me see, I didn't want to go down that far. The way we're going to solve those, since we cannot write them with the same base, we're back to solving exponential equations. I will take the natural log of both sides. And ln of e to the x is just x. You bring the x down, and ln e is 1. Remember I showed you that earlier? Ln e is 1, so that's just x, equals the ln of negative 8. We'll come back and think about that in a second. Ln of e to the x, which is just x, equals ln of 2. And we look at these two answers, and this problem right here we throw out. Because if you remember, you cannot take the natural log of a negative. That's something we talked about at the beginning of the chapter, which means my only possible answer is ln of 2. So you always have to be aware of extraneous solutions, which unfortunately brings me back to this problem, because I forgot that in these problems you need to check and make sure that your answers make sense. 188 over 99, that's going to be approximately, I'll tell you what, I didn't think about this. I should have thought about this. 188 over 99 is about 2. If you punch that in the calculator, you're going to get something pretty close to 2. And if I plug in 2 for my x, ln of 2 minus 12, that's a negative number. I cannot take the ln of a negative number. So even though our work was correct for number 4 here, 188 over 99, when I plug that in for x, I end up taking the log of a negative number, which is impossible. Same thing here. 188 over 99 minus 2, that's going to be pushing it. I think that's also going to be negative, but this one's definitely negative. So if you plug your solution back in and you get a negative number, you have to throw it out, and this problem actually is no solution. All the rest of the problems we did are solutions. I was thinking about that earlier when I was putting the problems together. How are we doing on time? 24? Yep, that's about what I was expecting. So that one actually is no solution because you cannot take the ln of or log of a negative number. Same thing on this problem when I got ln of negative 8. You have to throw it out because you cannot take the ln of a negative. All right, one last problem here. This one's kind of in the same form, or it is in the same form. 3 to the 2x I could rewrite as 3 to the x squared plus 2 times 3 to the x minus 8. And I'm going to make that same substitution where I see something squared plus 2 times something. If I plug in a for 3 to the x, and this is just temporary so I can work the problem, then that gives me a squared plus 2a minus 8 equals 0. And if I factor that, that factors a plus 2 plus 4. What am I doing? A plus 4, a minus 2, and then you get values a equals negative 4 and a equals positive 2. But that was just temporary. You don't want to solve for a, you actually want to solve for x. So now we're going to plug 3 to the x back in. 3 to the x equals negative 4. 3 to the x is equal to 2. And then we'll take the natural log of both sides. ln, take ln of everything. ln. And this problem I'm going to quickly throw out because I'm now taking the natural log of negative 4. You can't do that, so there's no solution for that piece. This one I can bring down that x, and that gives me x ln 3 equals ln 2. And then finally we will divide by ln 3, and the marathon video is finally over. There is your solution.